Today we'll discuss the questions related to moles and empirical formula. The first question, chemists use the concept of the mole to calculate the amount of chemicals involved in a reaction. Define the mole. So how you define a term mole? It is amount of substance which contain Avogadro's number of the particle or 6 exponent 23, not really atoms, because it is not necessary that it can be a molecule, it can be atom, it can be ions. So you cannot specify and say atom. It is amount of substance which contain 6 exponent 23 particles, because particle is a general term which can be used for atoms, molecules, ions. At its own atom for elements which exist in atomic state, like sodium, magnesium. But if element exists as a molecule, then 1 mole means 6 exponent 23 molecules. So it is amount of substance which contains 6 exponent 23 particles, or Avogadro's number of particle, we call that as mole. Now in this question, 3 grams of magnesium was added to 12 gram of ethanoic acid. The mass of 1 mole or one molecular mole is 24 grams for magnesium, and mass of 1 mole is 60. Which one, magnesium or ethanoic acid, is in excess? Excess means more than enough, and you must show your reasoning. How we can work out if we have the masses? So we can take the ratio of the mass. So what is the ratio of the mass for magnesium and ethanoic acid? This one is magnesium and this is ethanoic acid. So it is 2CH3 COH. For one molecule, the mass is 60. But if we have two molecules, the mass will be 2 multiplied by 60, so that will be 120. And what is the mass of magnesium? That is given 24. So one magnesium atom, the mass is 24. So ratio of the mass, according to equation, the ratio of the mass between magnesium and ethanoic acid is 24 is to 120. But in the question, if we have 3 grams of magnesium, then how much ethanoic acid we should have for a complete reaction? Example X. We have 12, but we don't know whether this 12 is more than enough or less. So if 24 grams of magnesium required 120 gram of ethanoic acid, so 3 grams of magnesium, according to question, 3 gram of magnesium, how much ethanoic acid is required for a complete reaction? So you need 15 gram of ethanoic acid. That is required for reaction. But you don't have 15. How much you have? You have 12. So what does it mean? Ethanoic acid is, this is what you have, 12 gram. And you need 15 gram. So which one you think is a limiting reagent? Limiting reagent means the reagent which will used up completely. So ethanoic acid, it means ethanoic acid will used up completely. So ethanoic acid is a limiting reagent. So which one is in excess? So here the magnesium is in excess. You can also solve this question other way around. Like example, you have magnesium and ethanoic acid. The ratio of the mass 24 is to 120. If I have 12, then how much magnesium is needed? X, cross multiply 12 into 24 divided by 120. What's the answer? 12 into 24 divided by, so 2.4. So what does it mean? It means 2.4 grams of magnesium we need for a complete reaction. This is what we need if we have 12 gram of ethanoic acid. But we have 3 grams of magnesium. So we have more than what we need. We need only, for a complete reaction, we need only 2.4. But we have 3 grams of magnesium. So what it shows magnesium is in excess. Because 12 gram of ethanoic acid require 2.4 grams of magnesium, but we have 3 grams. So magnesium is in excess. Is it clear, this part? So you will use this ratio and just write according to this. Whenever you're taking a ratio, you're finding how much amount you need. And according to question, you have 3 gram. So you have more than what is needed. That's why the magnesium is in excess or more than enough. The next part, how to get 120, because the mass of one molecule of CH3COH is 60. But in the question you have two molecules. So one is 60 and 60 multiplied by 2, that is 120. Then the next part, how many moles of hydrogen are formed? So how to get the moles of hydrogen are formed? Whenever you're finding the amount of product, you always take a limiting reagent, because magnesium is in excess, ethanoic acid is a limiting reagent. Limiting reagent means that will be used up completely. So whenever you're finding a product, you always find the product from limiting reagent. So in the question, they're asking how many moles of hydrogen are formed. So how to get the moles of hydrogen are formed? Nothing is given related to hydrogen. So what you can do, you have to use a ratio. First we'll take because the mass is given, so we'll take the ratio of the mass. Ratio of mass of ethanoic acid and hydrogen. So ethanoic acid, according to equation, 2 molecules of ethanoic acid gives 1 molecule of hydrogen. What is the total mass of 2 molecules of ethanoic acid? 1 molecule is 60, so 2 molecules will be 120. So ratio between hydrogen and ethanoic acid is 120 is to 2 in terms of mass. Ethanoic acid is 120 and hydrogen is 2. Why? Because one hydrogen is 1 and there are 2 hydrogens, so that's why it is 2. In the question, how much ethanoic acid you have, if you check amount of ethanoic acid, it's 12. So if you have 12 gram of ethanoic acid, how much hydrogen will be there? X. Cross multiply, you will get the moles of hydrogen. You will get the mass of hydrogen. What is the mass of hydrogen? That is 0.2 grams. So that is 0.2 grams is the mass of hydrogen, but in the question they ask moles of hydrogen. So how to get the moles from mass? The formula moles equal mass in gram divided by molecular mass. Because it's a molecule, so molecular mass. The mass in gram for hydrogen is 0.2 and the molecular mass of hydrogen is 2. So 0.2 divided, why 2? Because hydrogen molecule H2. So 0.2 divided by 2, that is equals to 0.1. Is it clear, this part? How many moles of hydrogen form? Because in the first part, we have to find the excess reagent. So ethanoic acid is a limiting. So whenever we are finding a product, we always use a limiting reagent. So we have ethanoic acid as a limiting. We need a moles of hydrogen, but in the question nothing is given related to hydrogen. So if nothing is given related to hydrogen, you have to use the ratio. But what you need the moles, but you don't have any moles, you have mass of ethanoic acid. So first you will take a mass ratio. If mass is given, take the mass ratio. If moles are given, take the moles ratio and then convert. So because the mass is given, that's why I'm taking the mass ratio. So the total mass of two molecules of ethanoic acid according to equation, one molecule is 60, so two molecules will be 120. And total mass of hydrogen will be 2. So ratio between them is 120 is to 2. But in the question, how much ethanoic acid is there? 12. So equation shows 120 is to 2, but in the question you have only 12. So hydrogen will be X, cross multiply. You will get the mass of hydrogen, which is 0.2 gram. But in the question you need moles. How to convert the mass into moles? The formula moles equal mass in gram. So moles equal mass in gram divided by molar mass. So mass in gram was 0.2 and the molar mass, molecular mass is 2. So 0.2 divided by 2, that is 0.1. So moles of hydrogen are 0.1, and here magnesium was in excess. Why there is only 1 mark? Because this question you can do in a short way. How you can do in a short way, short method? Look, I have 12 gram of ethanoic acid. If I have 12 gram of ethanoic acid, first I can also find the moles of ethanoic acid. How to find the moles? Mole equal mass in gram divided by molar mass, which is 60. When we write the molar mass, we don't check the equation, we write the mass of one molecule. So 12 divided by 60, what's the answer? 0.2. And now you have the mole, so you can take a mole ratio. So according to mole ratio, the ratio between hydrogen and ethanoic acid is 2 is to 1. So if you have 0.2 moles, this will be X. Cross multiply, you will get 0.1. So you can use any way to get the answer. You will get the same answer. Even first you take a mass ratio and convert into mole, or first you convert into mole, the mass into mole, and then take the ratio. Then calculate the volume of hydrogen formed. We have 0.1 hydrogen here, moles. How to get the volume of a gas from the moles? Which formula you use to get the volume of the gas? The formula which relate moles equal volume of gas in dm cube divided by 24. So that is a formula to relate the moles of a gas with the volume, and then 0.1 multiplied by 0.1 are the moles because it's divided by 24, so 24 will be multiplied. You will get the answer as 2.4 decimeter cube. Okay, in the next question, in an experiment, 25 cm cube of sodium hydroxide of concentration, so this is the volume of the solution, this is a concentration of the solution, was neutralized by 20 cm cube of oxalic acid. This H2C2O4 is oxalic acid. Calculate the concentration of oxalic acid. You have to follow the steps. Number one, calculate the number of moles of sodium hydroxide in 25 cm cube and zero point 0.4 mole per dm cube. So which formula relate the concentration and the volume of the solution to get the moles? So moles equal volume multiplied by concentration or concentration multiplied by volume. But keep in mind the volume should be in decimeter cube. So here the volume is in cm cube. You'll divide by 1000. So 0.025. So 0.025 is the volume. Multiplied by concentration is 0.4. What is the answer for this? Zero 0.024 multiplied, so that is 0.01. So you got the moles of sodium hydroxide. Then use your answer in part 1, the mole ratio or ratio of the moles to find the moles of H2C2O4, oxalic acid. What is the ratio of sodium hydroxide and oxalic acid? The mole ratio. 2:1. Because if 2 moles, so the simple mole ratio is 2:1. So if you have sodium hydroxide and oxalic acid, when you write the moles, the ratio is 2:1. So if you have 0.01 moles of sodium hydroxide, how many moles of oxalic acid will be there? It will be 0.01 divided by 2. Because 2:1 is the ratio, not 1:2. So it will be 0.00. 0.005 moles will be there for oxalic acid. Then the last part, we need a concentration. So we have the moles and we have the volume. How to find the concentration if we have both? We have the moles and we have the volume. How to find the concentration? So again the same formula which we use in the first part, that concentration, the concentration of the solution is equals to moles divided by volume. But volume in dm cube, decimeter cube. So moles were 0.005 and the volume was 0.02 because 20 cm cubes I have to convert into decimeter cube. What is the final answer for concentration? 0.005 divided by 0.02. That's equal to 0.25 moles per decimeter cube. Is it clear, this question? So first, I just repeat quickly, I'll repeat. First, we were having a concentration and volume. So we got the moles of sodium hydroxide. From moles of sodium hydroxide, we use a mole ratio to get the moles of oxalic acid. And from moles of oxalic acid and volume of oxalic acid, we got the concentration of oxalic acid. In this question, propene react with hydrogen iodide to form 2-idopropane. This is 2-idopropane, this is propene, and this one is hydrogen iodide. 1.4 gram of propene produce 4 grams of idopropane. So this is the practical value of the product. Practically we are getting this much. Calculate the percentage yield. So to calculate the percentage yield, you will not directly get the percentage yield. You will follow the steps which they provide, and at the last you will get the answer. First thing, moles of CH3, CH and CH2 reacted. How to get the moles? If we know, basically instead of writing in word, they write just a structure, but they are asking for moles of propene. How to get the moles of propene if the mass is given? So if we need the moles and the mass is given, the formula is moles equal mass in gram divided by molecular mass or relative molecular mass. We have the mass in gram, but we don't have relative molecular mass. But you can work out the relative molecular mass. That's why they give you the structure. It is 40, okay. So 1.4, I will show how you will get, because this compound contains 3 carbon. So it will be 12 multiplied by 3, which is 36. Plus this contains 3 plus 4 and plus 2, 6. So it will be 1 multiplied by 6. So that is equals to 1.4 divided by 42. That is equals to 0.003. Sorry, 0.33. 0.033. Is it clear? Because the structure was given. Using a structure, we can find the molecular mass. Molecular mass, just add the mass of each atom multiplied by the number of the atom of each element. You can get the molecular mass. Then the moles of CH3 that could be formed. Look, even though idopropane, this is idopropane or 2-idopropane. This is 2-idopropane. Now, why we, even though 4 grams of idopropane were given, but we will not use a formula here. Why we will not use a formula? Because this 4 gram is a practical value. Practically, we are getting 4. But what we want to find, we want the theoretical value, and theoretical value is always higher than the practical value. That's why we will not use this mass. We will use a ratio. And what ratio we will use? We'll take a ratio between propene and idopropane. So what is the ratio between propene and idopropane? Ratio of the moles. 1:1 is the ratio. So if I have 0.033, if 1:1 is the ratio of 0.033, so I will get the same answer, 0.033. Because if the mole ratio is same, like 1:1, that will not, or that does not make any difference to the product value. Maximum mass of 2-idopropane that could be formed. Mass of 1 mole or molecular mass is given. So if we have the moles and we have the molecular mass, we can find the mass in gram, because the formula is the same. Moles equal the mass in gram divided by molar mass. And if we need the mass in gram, that will be moles multiplied by molar mass. So moles are given 0.033. Mass in gram we don't know. Molar mass is 170. That is, they provided here. Mass of 1 mole means the molar mass. So 0.033 multiplied by 170. That is 5.61. So practically, this is the theoretical value. So theoretical value, theory suggests we should get 5.61 grams of idopropane. But practically we are getting only 4 grams. How to find the percentage yield? It is a practical value divided by theoretical value into 100. So practically we are getting 4. Theoretically we are getting 5.61 and multiplied by 100. So this is only 71.3%. So 71.3%, it is actually converted into the actually what we want. 71.3 or 71. Is it clear, discussion about the percentage yield? So whenever question is there related to percentage yield, the practical value will be given and you will find the theoretical value, and theoretical value should always be higher or it can be equal. if it is 100%, but practically you don't have a 100% result. That is why the theoretical value will always be higher than the practical value. When it is 71.3 percentage yield, what does it mean? Like example, it means if it was 100, like example, if I were having 100 gram of a reactant, I'm only getting 71.3 gram of a product. That is the meaning 71.3%. Or like I should get 100 gram of a product, I'm only getting 71.3 gram of a product, because maybe the reactant is not complete, maybe the reaction is not complete, reactants are not pure, maybe other reaction might occur. Another question related to percentage yield. In this question, using a 25 cm cube of sodium hydroxide of concentration 2.24, 3.86 gram of crystals were obtained. What are the crystals? Basically sodium sulfate or hydrated sodium sulfate. So this is the practical value of a product. We need a percentage yield. The first one, number of moles of sodium hydroxide. How to get the moles of sodium hydroxide? You have the volume and you have the concentration. Moles equal volume in dm cube multiplied by concentration. So when you multiply them, you will get 0.056. This volume is in cm cube, so it will be dm cube 0.025 and 2.24. 0.056 mole you will get. Then maximum number of moles of sodium sulfate dot 10 H2O. Now how to get this? Look, we have the moles of sodium hydroxide which were 0.056, but they are asking for hydrated sodium sulfate. So first, using a sodium hydroxide, we'll find the moles of sodium sulfate. How to find that? By using a ratio, because we don't know anything about that. So ratio between them is 2:1. If 0.056 moles are there, how many moles of sodium sulfate will be there? How many moles? 0.056 divided by 2. 0.028. And so it means we'll get 0.028 moles of sodium sulfate. But we need for hydrated. What is the ratio between sodium sulfate and hydrated sodium sulfate? That is 1:1. So the moles of sodium sulfate and the moles of hydrated sodium sulfate will be same. So that's why it is 0.28 0.028 moles. Then the mass of 1 mole of sodium sulfate or molecular mass is 322. Maximum yield, the term maximum yield means mass in gram. The maximum yield of sodium sulfate with 10 water molecule. So to get the mass in gram, you have the formula moles equal mass in gram divided by molar mass. So moles were there 0.028. Mass in gram you don't know. Molar mass is 322. That is the mass of 1 mole is also called a molar mass. 322 multiplied by 0.028. What is the answer? 9.016 gram. So 9.016 gram or 9.02, that is the theoretical value. The practical value is 3.86. So what is the percentage yield? The practical value 3.86 divided by theoretical value 9.02 multiplied by 100. So it shows that it is 42.8% having a percentage yield. Like you are getting about 42.8% what you should get. Practically, you are getting only 42.8% what you should get. Like if you should get 100 gram of a product, you will not get 100 gram of a product, you will only get 42.8 gram of a product. Is it clear, this part? Okay, moving on to the next question. The quantities of chemical expressed in moles can be used to find the formula of a compound, establish equation and determine the masses. A compound contains 72% magnesium and 28% nitrogen. What is the empirical formula? So I want everyone to use screen annotation to do this. You can do it other side as well. Mass of magnesium is 24 and mass of nitrogen is 14. The first step, divide by atomic mass. Second step, divide by smallest value. And the third one is round off. You can also make it separate. It's not necessary you solve on the same one. You can do it separately as well. Yeah, that's right, Mohsen. So when you divide by the smallest value, this will come out 1.5 and this will come out 1. But whenever one of the values is 1.5, 2.5, 3.5, so you have to multiply them by 2. So it is actually Mg3N2. Yeah, that's right. Thank you for your participation. Next one, we have to construct the equation. How to construct the equation? A compound only contain aluminum and carbon. 0.03 moles of this compound reacted with water to form aluminum hydroxide and 0.096. Write a balance equation. So if a compound contain aluminum and carbon, what will be the formula of the compound? Aluminum is group 3, so it will be plus 3, and carbon is group 4, it will be minus 4. So it will be, the formula of the compound is Al4 and C3. This reacted with water, excess of water means more than enough. And how many moles were there? We were having a 0.03 moles of this compound. It reacted with form aluminum hydroxide and methane. It formed 0.12 moles of aluminum hydroxide and it formed 0.09 moles of methane. We have to write a balance equation. How to make a balance equation? Basically, you take a mole, like in the equation, the element of the compound are always in a simplest ratio. And how to take a simplest ratio? I will divide by smallest value. So the smallest value is 0.03. This will be 1, this will be 4, and this will be 3. So here is 1, this will be 4, and this will be 3. So aluminum is balanced. Now we have to balance this equation. Aluminum is balanced, carbon is balanced. You have to balance hydrogen. How to balance hydrogen? Here you have 3 multiplied by 4, 12, and 3 multiplied by 4, as well as 12. So 12 plus 12, you need 24. To have a 24 hydrogen, you should have 12 water molecules, so that you will have 24 hydrogen. So now this equation is balanced in terms of all the reagents. So they give the hint here, because the mole ratio, look what happened when we have this question. They mention Al, aluminium and a compound which contain aluminium and carbon. So the formula according to valencies, aluminium is plus 3, carbon is group 4. Cross multiply, the formula will be Al4 and C3. It reacted with water, form AlOH3 plus methane. So they mentioned we were having 0.03 moles of this compound. It forms 0.12 moles of aluminum hydroxide and 0.09 moles of methane. Because in the equation, the formula, the compounds are always in a simplest ratio. So how to take a simplest ratio of these? I will divide them by a smallest number, smallest value, which is 0.03. So this will be 1, this will be 4, this will be 3. So what it shows, it means here we have 1 molecule, here we have 4 molecule, and here we have 3 molecule of methane. Now only thing what we have to do, we just have to balance hydrogen. 4 plus 4 multiplied by 3, 12, and 3 multiplied by 4, 12. So 24 hydrogen. So to have a 24 hydrogen, we should have a 12 water molecule, so that the hydrogen will be balanced. The next part, yes, even the second way, after constructing the equation, you can also put the number and try to balance in the way which you want to. That can also be done. In the second one, 0.07 moles of silicon react with 25 gram of bromine. Which one is a limiting reagent? But the problem in this question, for one substance moles are given, and for other substance mass in gram is given. You cannot compare moles with mass. You should have the same unit. So first what we'll do, we'll convert this mass of a bromine into moles. How to convert mass in gram into moles? Moles equal mass in gram divided by molar mass. Molar mass here, because bromine exists as a molecule Br2. This is how don't bother about equation. When you're using a formula, you don't have to see the equation. When you check a bromine, for bromine it is a group 7 element, it is 80. So it will be 25 divided by, because one molecule is 80, so sorry, one atom is 80, so two molecule will be means two atoms together make a one molecule, which will be 160. I'll less than a minute left, so I'll discuss this question as well. I think it was like the variant was different, which I was discussing. Yeah, this was I was discussing. I'll share another link.